That's why throughout USG Boral first technical webinar titled Essential Acoustics Consideration for Drywall Partitions, we are gathering today the industrial best practices for building materials and architectural finishes. Today we are presenting one integrated technical presentation, cover an interesting dimensions about drywall acoustics such as definition and background on acoustics, STC Guideline, example for wall partitions achieving various STC rating, and much more interesting subjects. This will be the first technical webinar hosted by USG Middle East, but it wouldn't be the least. We are planning to conduct 18 technical webinars in the coming time, as we are committed to provide always an innovative products and solution to build your products. USG Middle East operation has multiple manufacturing facilities based in Dammam, Saudi Arabia, Doha, Qatar, and Turkey, which allows to supply any projects in speed and high technical support. The acoustic systems considered as one of our main strength point, as we can supply acoustical systems up to 78 decibel wall partition and 1 NRC acoustical ceiling. The company has more than 1,300 registered patent, which is a result of our dedication of excellence and innovation. We are your single source manufacturer for acoustical ceiling and drywall partition. Kindly note that this session will be recorded and you will receive a copy of this video after the meeting is ended. I would like to thank all participants for joining us for the first technical webinar, and thanks to the summit webinar speaker, Mr. kmansour, our system specification lead. Kindly note that each participant will receive an 1 hour credit of continuing professional development CPD certificate after this webinar. However, we have started the AIA and the RIBA accreditation process for our webinars. However, both accreditation could stall due to COVID-19 situation. So let me leave the deck for my colleague Kmansour for his technical webinar. Karim.
Thank you, Musbah, for the introduction, and thank you, participants, for attending our technical webinar, which is the first of a continuous series of webinars. You will be getting a certificate with 1 hour CPD credit upon attending the full session. This is one of the 18 webinars planned for 2021, where some of the future topics will cover specialty ceilings, walls and ceilings for healthcare applications, cinema walls and ceiling solutions, roof board solutions, drywall structural design, and many others. Good morning all, and welcome to USG Middle East webinar on acoustics for drywall partitions. I am Kmansour, specifications lead at USG Middle East, and I will be presenting to you today this challenging topic in modern construction. Please prepare and send your questions immediately in the live chat, as we will be answering your questions at the end of the webinar. USG Middle East manufactures and supplies drywall partitions and ceiling products that control sound to make buildings more functional, productive, and comfortable. Acoustical design can be one of the most complex facets of architecture and construction. Depending on the purpose of a building or room, primary acoustical requirements could include sound control between spaces, sound control within space, or listening efficiency in meeting rooms and auditoriums. Just as technical challenges can vary widely from space to space, so too the choices of materials and design details that can meet them. Exploring these options require time and effort. However, this investment can yield important benefits such as happier tenants, higher property values, reduced turnovers and vacancies, and greater productivity. In this webinar, you will learn about acoustic definitions, background on acoustics, STC rules of thumb as per design, STC versus level of privacy, STC guidelines, We will be giving examples of wall partitions achieving various STC ratings, and there will be examples of construction details to maintain the designed STC, whether it's a seal detail, resilient channel installation detail, control joint detail, doorway placement, HVAC design details, electrical boxes, cables and wiring, and wall ceiling intersection. Some of the most important terms and concepts to be familiar with and used in drywall acoustic designs are flanking paths, which are small gaps and openings around doors, floors, tracks, electrical boxes, and conduit, and HVAC ducting that allow sound to pass through if not filled with acoustical sealant, also called as leaking paths. The second definition is the impact isolation class, also called IIC, which is the measurement of the ability of a floor ceiling assembly to isolate sound from football or other impact sources, reducing the intrusion of noise into rooms directly below. The third and important definition is the sound transmission class, which we will elaborate more about throughout our presentation. Sound transmission class stands for STC, which is the measurement of the ability of wall or floor assembly to isolate airborne sound and prevent it from passing from one side to the other. The frequency range to determine STC is from 125 to 4000 Hertz, and the STC is determined by ASTM E413. RW is the weighted sound reduction index, where the frequency range to determine RW is from 100 to 3150 Hertz. From a curve, the RW is determined using ISO 717-1, and we will be giving an example of the graph and how to read the RW and the STC throughout the presentation. Note that whether a test is conducted to either ISO or ASTM, the RW or STC can be calculated. While the science behind sound is well understood, using that science to create the desired acoustical quality within a building or room is complex. No single acoustical solution can be universally applied to all designs. Each environment features unique parameters the architect and designer must consider when developing floor plans, selecting materials, and designing assemblies. Virtually every material, from furniture, wall and floor coverings to computer equipment, will affect sound to some degree. Designing wall partitions, ceiling systems, and floor ceiling assemblies for a distinctive quality of a space will achieve the most effective sound control. Sound is defined as a vibration in an elastic medium that is any material, air, water, physical object that returns to its normal state after being deflected by an outside force, such as a sound vibration. More elastic a substance, the better it can conduct sound. Lead, for instance, is a very inelastic and therefore a poor sound conductor. It's used usually in X-ray rooms of hospitals with gypsum board. Steel, on the other hand, is highly elastic, making it an excellent conductor of sound. Sound travels not only in a straight path from its source, but also it bounces off partitions, bends around barriers, and squeezes straight path through small openings as well, all of which can allow noise to reach surprisingly far beyond its point of origin. Designers must consider the dynamics of sound when determining how they will control noise within a building. Sound insulation relates to the actual reduction in sound traveling from one area to another through a wall, floor, or ceiling. Sound transmission class is the measurement of the ability of a wall assembly to isolate airborne sound and prevent it from passing from one side to the other. Typical sound pressure levels are listed, where the sound pressure level is 140 decibel for military Air Force jet takeoff. Large aircraft is 110 decibel. Conversational speech is 60 decibel, and breathing is 10 decibel. You can measure these decibels using a special measurement tool. Inside the room, if you want to measure the sound inside the room, and you get a machine, if you have a ringing phone and you measure it, it will give you 70 decibel, for example. What is the basic concept of how acoustical walls work? We have already defined sound transmission class, STC, as the measurement of the ability of a wall assembly to isolate airborne sound and prevent it from passing from one side to the other. When a wall has an STC of 25, it implies that normal speech can be heard easily. STC of 30, loud speech can be heard easily. STC of 35, loud speech can be heard but not understood. STC of 42, loud speech can be heard only as a murmur. STC 45 must strain to hear loud speech. STC of 48, only some loud speech can be barely heard. STC of 50, loud speech cannot be heard. As an example, to lower the sound pressure level from conversational speech at 60 decibels to a breathing at 10 decibel, we need a wall partition achieving STC of 50, which is 60 minus 10 decibel. So, for example, in one room, if you measure the conversational speech with a certain machine, it will give you 60 decibel. If you want to hear a breathing in the other room, then you need a wall partition to be separating this room and the other room to achieve 50 decibel. So 60 minus 50 is 10 decibel. You need a wall partition achieving STC of 50. Let us, for example, now consider the wall partition achieving STC of 50. If we compare the acoustical performance of a wall partition of STC 47 to a wall partition with STC 50, this is a reduction level of 0 to 3 decibel. Then the perception is very slight, and you barely notice the difference between these two partitions acoustically. If the reduction level is 4 to 5 decibel, it's clearly noticeable. If the reduction level is 7 to 8 decibel, then there's a major reduction in perception. Comparing a wall partition achieving 40 decibel to a wall partition achieving 50 decibel with a reduction level of 10 decibel has a substantial reduction in perception. It will be very substantial comparing a wall partition achieving 40 decibel to 50 decibel. The frequency range to determine RW is from 100 to 3150 Hertz, and STC is from 125 to 4000 Hertz. In this example, at 500 Hertz, RW is 50. At 500 Hertz, STC is 49. This is a good example of why RW and STC differ. If the project acoustic specifications demand RW of 50, then this wall could be offered. However, if STC 50 is required, then you would need to offer a modified wall partition at a more expensive rate, since this wall partition achieves 49 decibel. Sound insulation ratings rule of thumb for STC and RW. In most cases, RW is approximately equal to STC. Note that STC and RW are lab results only. If a test is done to ASTM, then both the STC and RW can be determined from the test results. Likewise, if a test is done to ISO, both RW and STC can be determined. The frequency range of STC determination, as we mentioned earlier, is from 125 to 4000 Hertz, and RW is from 100 to 3150 Hertz. STC has the 8 decibel rule, which is maximum deficiency at one frequency. The 8 decibel rule is dropped for RW. FSTC is determined in the field, and a lab test result will typically be higher by up to 5 decibel. Also, this same wall tested in another project may achieve a different result because of different site conditions, and we will be discussing more about FSTC. ASTM E336 is the single number ratings test method for field sound transmission class, FSTC, noise isolation class, NIC, and normalized noise isolation class, NNIC. DNTW is the weighted sound level difference and ISO 717 and 140 ISO field test. A wall partition will achieve an FSTC on site approximately 10% less than the STC tested in the lab. For example, if you have a tested wall assembly in the lab that is achieving 55 decibel, then when tested on site, it will achieve an FSTC, field STC of 50. Likewise, 66 decibel tested on the lab will give you an FSTC of 60. Have you ever asked yourself, how is a wall partition acoustical performance affected when you double the layers of gypsum, thus doubling the mass? When mass is doubled, sound insulation increases by 4 to 5 decibel. 2 layers of gypsum board would be giving you a 31 decibel rating. When we double the layers to 4 sheets, we are having now a mass of 34 kilograms per meter cube, which is 4 times the mass of each layer of gypsum board. The rating becomes 35 decibel. By doubling to 8 sheets, you will be getting an acoustical performance of 40 decibel, and you see that the mass of the system from 34 it went up to 68 because we doubled the sheets and we doubled the mass. We gained 5 decibel acoustical rating. Consequently, having 16 sheets will give you an acoustical performance of 45 decibel, and having 49 decibel for 32 sheets of gypsum. However, in real life, you don't see a wall partition composed of 32 sheets, and you don't put the 32 sheets of gypsum board next to each other. Typically, a wall partition is composed of a steel framing separating these gypsum board and insulation in order to increase the acoustical performance. So you will never see 32 sheets next to each other. There are more factors that we are going to talk about in the STC rule of thumb design as we continue. Here you can see a single framed wall partition composed of a single frame stud and insulation and regular gypsum board, 1 layer on each side. This typically will give you a 43 decibel. Now you will see how does the acoustical performance and the STC vary depending on the factors that we change within a wall partition. We mentioned that doubling the mass will increase STC by 5 decibel. So you see that when you add an additional layer of gypsum board on each side, you gain 5 or to 6 decibel, as you can see in the figure. Doubling the mass will increase STC by 5 decibel. Adding insulation. You see here, when we got rid of the insulation, we lost 6 decibel. Adding insulation to this wall partition where we lost the 6 decibel will give you an increase of 5 to 9 decibel. Of course, that is depending on the thickness of the insulation, on the density of the insulation, on the type of insulation used, whether it's fiberglass or stone wool or mineral wool insulation. However, having insulation in the wall partition will definitely benefit the acoustical performance of your wall partition by 5 to 9 decibel. Steel studs at lower gauge. Let's say you have a steel stud that is 0.6 millimeter thick. They perform better than higher gauge steel studs or wood studs. If you have a higher gauge stud of 0.9, the 0.6 millimeter steel stud will perform better acoustically as a system than the 0.9 millimeter stud. From 0.6 to 0.9, you actually have 0.7, 0.8, and 0.9 to reach 0.9. For each 0.1, you're actually losing 1 decibel. So having a wall partition with studs of 0.7 will be 1 decibel less than having a wall partition with 0.6. Likewise, for 0.8, it will be 2 decibel less. For 0.9, it will be 3 decibel less. So this is just a rule of thumb, as we mentioned earlier, that sound travels differently through air and steel framing and lead, each in a different manner. Adding a resilient channel will increase STC by 5 decibel. And we're going to see an example of a wall partition where when we added a resilient channel, it gained 5 decibel. We will see it in the presentation. However, we will also see the installation detail of a resilient channel, how it's installed, as if the resilient channel is improperly installed, it will not give you the 5 decibel increase. So there's a proper way of installing a resilient channel. Considering double frame will increase STC by 8 decibel. If you have a single frame compared to a double frame, the twin frame steel stud, which is composed of 2 C studs next to each other, separated by an air gap and layers of gypsum board as well, it will give the system an increase of an decibel. And typically, these twin frame wall partitions are used in theaters and cinema application where acoustical rating is high. Acoustical rating is required. The acoustical rating for a twin frame wall partition composed of 2 layers of gypsum on each side, fire rated with double steel stud, will typically give you a 66 decibel, and we will be talking about this assembly. However, USG Middle East systems were able to reach up to 78 decibel for cinema applications for theaters, as my colleague Mr. Misbah mentioned earlier in his introduction. How does STC relate to privacy? A wall partition achieving 45 decibel acoustical performance has a normal degree of privacy, where normal voices in adjacent space are audible and intelligible some of the time. Raised voices and speakerphones are mostly intelligible. A wall partition achieving 50 decibel acoustical performance has a good degree of privacy, where normal voices in adjacent space are barely audible but unintelligible most of the time. Raised voices and speakerphones are partially intelligible. A wall partition achieving 55 decibel acoustical performance has an excellent degree of privacy where normal voices in adjacent space are mostly inaudible. Raised voices and speakerphones are audible but intelligible some of the time. A wall partition achieving a 60 decibel and plus has an acoustical performance that's considered a confidential degree of privacy, where normal voices in adjacent spaces are not audible. Raised voices and speakerphones are barely audible but not intelligible. You might ask yourself, based on what do I select the components of a wall partition to achieve a certain STC rating? For example, what should be the STC rating of a wall partition between areas in a cinema? Or what should be the STC rating of a wall partition between classroom and offices in an educational facility? Thus, and based on many standards, there should be an STC guideline depending on the type of building being constructed. USG Middle East has developed STC guidelines for various types of buildings. We will discuss first the cinema wall acoustic performance table, where you can see from auditorium to public area, we have tested a wall partition composed of 2 layers of 15.9 millimeter sheetrock type X gypsum board on each side with cavity insulation and studs and steel framing as a full system to achieve an acoustic rating of 66 decibel. We go back to FSTC, the field STC, the test when the partition is tested on site. So from the same wall partition, when tested on site, will achieve a 60 decibel acoustical rating. Another assembly that is tested and in one of the laboratories, and there's a certificate for the acoustical test that you can have, and it's published in our cinema guide. A wall partition between auditoriums shall be composed of 3 layers of 15.9 sheetrock type X on each side with insulation in the cavity to achieve 71 decibel. And likewise, when this assembly is tested on site, it will give an acoustic rating of 65 decibel. Extreme wall 1, we use the 3 layers of type X gypsum, 15.9 millimeter thick, with 1 layer of fiber rock, which is an impact resistant board on the outside. It achieved a 72 decibel rating. For cinemas, we also have Extreme wall 2 achieving 74 decibel acoustic rating. And the last wall partition is the IMAX wall partition, which is achieving an acoustical performance of 78 decibel. You can also be able to see all the details of the wall partitions when you're working on a cinema in the cinema guide that is posted on our USGME website for walls as well as for ceilings. Products from USG Middle East for your ceilings and walls are posted on our website and the guide as well. When considering an educational facility, the minimum acoustic rating between 2 classrooms shall be 45 decibel. Whereas if you consider 2 music rooms, the acoustic rating reaches a confidential degree of privacy that we mentioned earlier of 60 decibel. You can at any time go through this acoustic guideline as well using our educational institution guide. When considering businesses, the minimum acoustic rating between 2 offices shall be 45 decibel, and the maximum acoustic rating between general area or conference room and kitchen shall be 55 decibel. When considering hotels, please note that the acoustic performance differs depending on the hotel R rating. As shown in the STC guideline in the hotel's guide, 5-star hotels has a more stringent acoustical performance than 4-star and 3-star hotels. Acoustic rating between restaurants and mechanical equipment rooms is the highest for 5-star hotels at 61 decibel. Moreover, acoustic rating between restaurants and lobbies and reception areas is 50 decibel for 5-star and 4-star hotels. Acoustic ratings between guest rooms is 65, 55, 50, and 7 dB respectively for 5 stars, 4 stars, and 3 stars hotel. You may notice that there is a wall reference number for each respective acoustic rating. For full information related to hotels and description of wall partition types, please visit our website and download USG Middle East Hotel Guide. Hospitals also have acoustical performances to consider design, where a wall partition separating 2 patient rooms can have an acoustic rating of 45 decibel and 50 decibel, represented by wall assembly HCW1 and HCW2. Also, the acoustical performance to consider between patient room and service area is 60 decibel, represented by wall type HCW7. Other rooms have other requirements and are represented by different wall types. For full information related to hospitals and description of wall partition types, please visit our website www.usgme.com and download USG Middle East Healthcare Guide, where you won't only see the wall partitions, you will also see the special healthcare ceilings that are available to you from USG Middle East. Healthcare ceilings achieving different criteria. Here you can see an example showing the components of healthcare wall 1, HCW1, which gives an acoustic rating of 47 decibel and a fire rating of 1 hour. This wall partition is composed of 1 layer of 15.9 millimeter sheetrock brand type X gypsum board applied horizontally and vertically on 70.5 millimeter C-studs spaced at 600 millimeter on center. You see the system wall thickness is around 96 decibel, including the steel framing and the gypsum board. It achieves 1 hour fire rating as per UL U419. And it's composed of all these accessory items. When you have tested wall partition for acoustics and for fire, you have the full components of the system, whether it's the sealant, whether it's the screw, the tapes, the joint compound, the gypsum board, the steel framing, all the components you will have as one assembly. This is an assembly containing all these components to achieve the acoustical performance required. This is another example of HCW2 where you can see USG Middle East Healthcare. You can see it in the healthcare guide. Even in wet areas of healthcare applications, there's a special wall partition HCW5 achieving an acoustical rating of 50 decibel. Here is HCW7, where you see the addition of the resilient channel. We saw previously the wall partition with 2 layers of gypsum board achieving 2 hours fire rating and 56 decibel. When we added the resilient channel, we gained 5 decibel, which is 56 plus 5, 61 decibel. You can refer to all these wall partitions from USG Middle East website, www.usgme.com. Installation plays a critical role to achieve the required design. In the following examples, we will be highlighting some proper installation practices to maintain the design and performance. You might design a wall partition to have an STC of 50 or 55. However, if not sealed properly beneath the track and the gypsum layers, the STC might drop to 29. We here conclude that proper installation is crucial to maintain the required design intent. Here you can see that you should place acoustical sealant beneath the track and below the first layer of gypsum board. As we mentioned earlier, that adding a resilient channel enhances the acoustical performance by almost 5 decibel. However, if the screw going through the gypsum board and the resilient channel is installed improperly, going all the way through the stud, then a short circuit will happen and you won't benefit from the addition of the resilient channel. The first figure illustrates the resilient channel installation to avoid, and the second illustrates the correct method of installation. Remember, improperly installing a small item like a screw might have a major impact on the acoustic design of a wall partition. In this slide, you can see the proper way of installation of a control joint in case you have a 1 hour fire rated wall partition as illustrated, where you can put 2 cut pieces of sheetrock brand fire coat core panels in the cavity behind the studs, as in the first figure, or compressed insulation as in the second figure. Even doorway placement during a design would impact the acoustic design. The first figure illustrates doorway placement to be avoided, and the second figure illustrates a better doorway placement, where it is harder for sound to propagate from one room to the other as the doors are not facing each other as in the figure. Sound also propagates in HVAC, thus design illustrated here should be avoided. We have come across many cases where one of the conference rooms was the sound was being heard to the other room. Sometimes it's no matter how good the ceiling is or the wall partition is, sometimes the issue is with the HVAC design, and the sound is propagating through the HVAC system to the other. So from the design phase, HVAC design should be considered also for acoustical performance. For example, here, a better way to design HVAC is shown in the first figure, and the recommended way is shown in the last figure. The sound wave gets broken the most and dissipates. When installing a cabinet between 2 studs, a gypsum panel shall be installed on the back of the studs behind the cabinet to accommodate for the loss of gypsum board face layer. Electrical boxes shall be staggered as shown in the second figure, and the installation in the first figure should be avoided. The recommended electrical boxes installation shall be as illustrated here, with 24-inch or 600 millimeter minimum separation. The general partition construction to help achieve the suggested ratings shown in acoustical separations are as follows. How to install electrical sockets and penetration. The partition construction details and closure conditions must maintain the acoustical integrity of the separation. The following details should be developed in the detail design. The electrical and service outlets are positioned less than 600 millimeters apart. The outlet boxes shall be enclosed by 2 layers of gypsum board with loaded vinyl layer at the perimeter of the socket box. As for pipes and ducts, all gaps around penetrations, duct pipes, conduit are to be sealed with sealant. Multiple layers of drywall are to be applied with staggered joints. Duct and pipe penetrations through gypsum shall be carefully sealed to avoid sound leakage. When considering cabling and wiring, all gaps around penetrations, ducts, pipes, conduits are to be sealed as follows. 25 millimeter or less gap filled tightly with batt insulation and or fire sealant. Gaps larger than 25 millimeter filled with heavy density putty. Fire ratings of materials to be verified also by professionals. What about the intersections between walls and ceilings in case the wall is not reaching all the way to the soffit? On the top of the freestanding wall partition, there shall be a compressible gasket between the T-grid and the top track of a wall partition. In case of a concealed ceiling, the design detail will be as illustrated in the second figure. What are the walls and ceilings STC and CAC rules of thumb? How is the STC related to CAC when you have a drywall partition and the ceiling as well? As a rough guide to ensure the acoustical performance of a wall is not degraded significantly by the flanking through over partition ceiling path, the CAC of a ceiling should be a minimum 3 decibel higher than the RW of the wall. For example, an RW dividing wall requires a minimum CAC of 43 decibel ceiling. For RW 35 and 40 walls, there are options that don't require the wall linings to extend full height. RW 45 walls will require the plasterboard lining on one side to extend to the underside of the slab above the ceiling, as if the ceiling is mineral fiber, since there is no mineral fiber panel that can provide a CAC of 48 decibel. RW50 will require the plasterboard linings on both sides to extend to the underside of the slab above. Thank you for attending this webinar, and please always remember to visit our website at www.usgme.com. Now we'll be answering the questions that you have raised. Please note that at any time you can send questions related to projects you are designing or constructing to kmansour@usgme.com, and I will be more than happy to answer you. And whether you're working on projects under design or during execution, feel free to involve us with your projects, and we'll be providing the support that you may require.
Thank you, Karim Mansour, our system specification lead, for this great technical webinar. Again, as what we have said in the beginning, that this was our first technical webinar for USG Middle East, but it wouldn't be the last one. We are planning to conduct an 18 technical webinars in the coming time, since we are committed to provide an innovative products and solution to build your products. Again, please note that each participant will be receiving an 1-hour credit of continuing professional development, CPD, after this webinar. And now going, Karim, to the questions and answer session. Please just send us your questions to the chat box so we can answer immediately. Karim, I have here a couple of questions. The first question is from Mr. Gerald Stewart, that he don't agree to the level that you have provided in slide number 5. If you can go back please for the 50th slide, Karim. You provided that a 50 with loud speech can be heard on the other side. The 60 minus 10 is not correct. So this is from slide number 5, the question, Karim. For this is the first question. That 50 with loud speech can be heard on the other side. So the 60 minus 10, which is equal 50, is not correct. It should be 50 minus 60 minus 50.
Yes, it's no, the breathing. If you're in one room and you're hearing a conversational speech of 60 decibel, and in the other room you want to hear the breathing, then you have to have a wall partition achieving STC of 50, which is 60 minus 10 is the 50. Having a wall partition
60 minus 50, Karim.
60.
Yeah, I'm sorry, I don't actually agree with that. Gerald Stewart here. I'm Secretary of the Middle East Acoustic Society, Principal Acoustics at Inhabit Group. 60 minus 50 equals 10 is not the correct assimilation. The STC curve is a curve fit. So there's different sound levels that occur at different points in time and at different frequencies. So the assimilation is not correct. It's not just a straight this minus this equals this. And the second part of that, to hear breathing in another room at 10 dB, you would probably have to have something like an STC RW80 or 100 wall, because you're actually in a breathing of 10 dB, you're in an anechoic chamber. I just don't agree with the slide, I'm sorry. But however, you did correct it in a later slide where you said that, you also said that there was a 50, that loud speech cannot be heard. If you go to about 4 slides later, you said that 50 loud speech can be heard and 60 is in the privacy rating section. If you go into the privacy rating section.
STC.
Yes.
Yeah, that's the one. You've got then a 60 plus normal voices in adjacent spaces are not audible, but raised voices and speakers are barely audible. Okay, so you've actually corrected yourself in that slide. Your first slide slide 5 is wrong. This slide is more like it.
Thank you, Gerald, for the note. We will note that. Thank you.
Okay, and the second part, STC and FSTC, you've said that FSTC at 55 will give you an, STC 55 will give you an FST 50, but you've then said STC 66 will give you an FSTC of 60. I'm just wondering why there's 1 dB difference between the 50 and the 60. Wouldn't they both be 5?
Yes, we typically said that approximately it's a 10% difference between the lab tested and it's just an approximation that it will be 10%. So 10% of 66 is 6 decibel. That's why it's 60 minus 6, 60 decibel.
I think if you go to ATSME, it actually gives you 5 for all.
Would be around 60 or 61, you're saying?
Yes, correct. Yeah.
Okay.
It's globally recognized as being 5.
But there is again from 5 to 10% difference between the field test and the sound test in the site. Karim, there is a third question for the how many wall types we have tested?
How many wall types we have tested? For cinemas, we have tested 5 wall types, 1 wall type achieving STC 66, 1 wall type achieving STC of 71, the other wall type 72, 74, and 78. However, we have tested many other assemblies other than the cinemas. It can be, I cannot have the exact number, but it might be over 30 tested assemblies in the lab.
And all are available to our online website. For Mr. Larry Sapio, again, he said that thank you for this presentation. And from Tara, question if we can share the slide as PDF. Yes, sure. We will be sharing the slides in PDF format, and a copy of this, a link for this webinar will be shared once it's ready online. This is the question so far. Please just feel free to drop us questions so we can answer them immediately if you have any technical question for this webinar. And again, thanks, Mr. Gerald, for the valuable inputs for this technical webinar.
Yeah, most welcome. Most welcome.
Thank you. So we'll be giving around a couple of minutes. If you have any technical questions, you can just raise it immediately. Or as my colleague, Mr. Karim has explained, that his email was sent to everyone for this session is kmansour@usgma.com, that you can approach him at any time for your technical query. So we'll wait a little bit, Karim, if we have any other further questions.
Can I ask?
Yes, please.
Hi, I'm Firas Jeddah from Jordan.
Hello.
I want to know the specification for the doors on the partition wall or the drywall. What the specification for the steel door?
In terms of acoustic?
Yeah, acoustic door.
Acoustical door, if you allow me, Karim, to jump here. Acoustical door always should have 5 decibel more than the wall itself. So to maintain the same integrity of the wall partitioning of acoustic, similarly to the fire, it should be always 15 to 30 minutes more than the tested wall. So there is a further criteria for the comparing to the wall. And not only wall, it's opening, any opening. When you say opening, walls and windows, if it's movable or fixed windows.
Yes. So
there is a coefficient between walls and openings within the wall, within the building itself.
So do you have a drawing or something on the slideshow for the steel doors?
We are not a steel door supplier, but however, we can give you a convenient support for the hollow metal doors with a different insulation, whether it's stiffened or not stiffened. We can give you a full guidelines also for the door, if you can just adapt that.
Yeah. However, as USG Middle East, we manufacture the components for the wall partitions and ceilings only. We don't manufacture the items for the doors or doors. That's why our specialty is walls and ceilings only.
Yes, however, and Karim, here is the role of the designer and the architect to make the integration properly between all elements of the building, between the wall and the mechanical parts of the building, such as the door and windows. So here comes the challenge, and here comes the manufacturer support, where we can help in defining the proper STC guides, fire performance mechanics, and these things. Here is the how we can integrate. I said that we have the collaboration is one of our main values the company builds, is to work very close with the stakeholders. So if you can just please again for the door, we can connect you and we can give you a detailed drawings for door from other partners which we work with.
Yeah, but I want to say something that you know that the steel door, the frame goes from inside to outside. So any noise, any sound comes from outside, it will comes with the frame. So
which kind of doors? Fire-rated doors or non-fire-rated doors?
Let's say steel doors, not fire-rated doors. steel doors or fire-rated doors, the same drawing, the same
The
shape.
fire-rated
That's why.
doors, usually the frame will come with a wood frame as per the UL standard. So once this is as per the UL 10C. So the wood frame will have an mineral wool inside insulation, which will assist the STC and the fire performance. But for the whole metal door, if it's non-fire rated, there is two kinds of frames, which is the knockdown and the normal frame, which is will be with the grouted inside. So this will reduce. I agree with you. This will reduce the STC performance if it's non-fire rated and they use the knockdown frame.
That's the point.
Yes. So it should be the frame should be built before the wall, not after.
Yes. Okay. Thank you.
I hope that you answered the question.
Yes. Thank you a lot.
Thank you. Karim, another question from Mr. Abdul Razak. What is the use of resilient channel using in sealing instead of firing a channel? Can you please explain?
Yes, we have one sealing assembly achieving 2 hours fire rating, where it's composed of three layers of gypsum connected to furring channels. However, the fourth layer, the ceiling is composed of 4 layers, but 3 layers are connected to the furring channel, and the fourth layer has a resilient channel connected to it. Sometimes the resilient channel is used in drywall ceilings to carry the fourth layer of the gypsum board when it's connected. There's also some acoustical advantages for that, as well as the full system will be able to carry the 4 layers. We can share the UL certificate of that system with the gentleman.
Thank you, Karim, for answering the question. I have another question. At any labs, this question from Mr. Samir Al-Shawi, at any labs, you do the test and it's approved in civil defense in KSA?
Civil defense and KSA, he means for the fire tests?
Yeah, civil defense should be for safety.
For the fire. USG has over 334 UL assemblies. The civil defense of Saudi Arabia recognizes UL laboratories and tests from UL assemblies. So when you go to the UL certificate issued by UL, you will see the name of USG Boral gypsum board on the actual certificate. This is accepted by the civil defense of Saudi Arabia.
But at any labs, we do the test usually. Sometimes we do the test as a pre-active, as a projection, and we do have a library of tested. And sometimes for a certain projects, the consultant or contractor, they are requesting for a certain wall performance for more than acoustic. It's including the mechanics, acoustic, fire. And that's why we can do the test accordingly for a certain projects, for a certain wall construction, which will be used only for this particular projects. So it's very flexible, the testing, and it's according to the project requirements and the consultants' approvals. Karim, another question from Mr. Amin Shahade regarding the hotels. You have mentioned a 5-star hotel. The STC requirement will be changed if it's 4-star hotel. If yes, the same drywall will be specified. Thanks. If you go, Karim, to the STC guideline hotel, please.
Yes. As we mentioned, the requirements of 5-star hotels are more stringent in acoustics than 4-star or 3-star hotels, where the 3-star hotels will have the least requirements. So the wall partitions, yes, they differ from 5-star hotels to 4-star and 3-star hotels.
So the STC requirement will vary?
Vary, yes.
Okay. Another question from Mr. Borno Tayo. I want to know if the values of partition sound rating are standards.
Values of partition sound rating.
I want to know if the values of partition sound rating are standards. So there is any standardization for the STC guides?
Each company, when test their assemblies, they have different values. It's as per the test result that you will be getting, but the assembly will differ from one manufacturer to the other. However, as per the building and international building code, there are some we based our guidelines based on the international building codes available. So, for example, the FGI code 2018 for healthcare applications gives you how much the wall partition assembly should be between patient room and patient room, and it's stated in our healthcare guide. So there are some norms and standards to follow.
We have the last question here is what is the difference between STC, the sound transmission class, and OITC, the outdoor-indoor transmission class? Is there any specific differences of the OITC? According to the norms, the OITC, Karim, is the number of rating the sound transmission loss of constructed assembly tested with the lower frequencies. So when you test with the lower frequencies, there is any the variant that tested between STC and OITC?
Usually, for example, our wall partitions at low frequency for cinemas, we were able to meet the criteria of those tested assemblies. However, if he can send we can reply by email.
Sorry, Musbah, that is incorrect. OITC is measured performance for outside to inside. Yes, it's outside to inside with the low frequencies. If it's outdoor, indoor, OITC is outdoor, indoor transmission class. So
can we receive
outdoor, indoor?
Sorry, it's Gerald Stewart here again.
Yeah, Gerald.
OITC is outdoor-indoor transmission class, and it's typically a measure of a facade assembly. It's a completely different measure to STC, and the two should never be confused. It's a totally different measure. So if anyone wants to actually email me direct, I'm happy to provide details on that. But the answer that you've been providing so far is not correct. I'm sorry.
So it's for the exterior facade?
Yes.
Thanks, Gerald, for this second clarification. So, do we have any further questions related to the essential consideration for acoustical drywall partitions? So thanks everyone again for attending this first technical webinar. Thanks for all participants for accepting our invitation and attending this. Thank you, Karim, for this wonderful technical presentation. We will keep in touch and we will send you the technical the handouts. It will be shared with you on the each of you email. And again, I will mention here Karim Mansour email address, so anyone can share with him any questions. And here, our website to be recognized for everyone. Thank you again, and have a wonderful day. Thank you.
Thank you all.
Thank you.
Hello.
Thank you, sir.
Sir, एक order is placed.
Thank you very much, Mr.
Thank you, Karim, for your wonderful presentation. Much appreciated.
We enjoyed it. I enjoyed it personally, and I'm sure we will get in touch with you as and when our inquiries come from. This is from Contra, Jalal Group from Bahrain. Thank you very much, Musba and Karim, once again.
Thank you. Thank you. Thank you.
Thank you.